Part 2 starts from here. Next question. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. When 10 grams of calcium carbonate is decomposed completely, then 5.6 grams of calcium oxide is formed. Calculate the mass of carbon dioxide formed. Which law is used to solve this problem? In this question, we need to find this missing value, and we need to tell that which law we'll be using to solve this problem. So before answering this question, let us follow this step. So the first step is to analyze what is given and what needs to be found. The given values are calcium carbonate, which is 10 grams, and the calcium oxide, that is 5.6 grams. And we need to find the mass of carbon dioxide formed. So the second step is to write the chemical equation, and for that we need to figure out the reactants as well as the products. So let's read the question again. Calcium carbonate decomposes. That means initially calcium carbonate is present, so this is the reactant. Decomposes on heating to form calcium oxide and carbon dioxide. So these two were formed as a reaction of heat on our calcium carbonate. So that means these two are products. So now let us write the equation. Calcium carbonate on heating decomposes to calcium oxide and carbon dioxide. So now we know the equation, and the question arises that which law we will be using to solve this equation. So what we're going to do here, first of all, we'll see whether this equation is balanced or not. If this equation is balanced, then we can apply law of conservation of mass, because if you see in the question, the mass of the reactant is given and the mass of one of the product is given. So it's easy for us to apply this law of conservation of mass, provided if this equation is balanced. If it is not balanced, we need to balance it in order to apply law of conservation of mass. Let us balance this equation now. First of all, we need to balance the number of atoms of metal as per the rule for balancing. So in this equation, the metal is calcium. So on the reactant side, we have just one atom of calcium, and on the product side also we have just one atom of calcium. So this is balanced. Now balancing the number of non-metals other than hydrogen and oxygen. So here we have carbon. Here we just have one atom, and on the product side also we have just one atom. So this is also balanced. In this equation also we don't have hydrogen atom, so we will balance the number of oxygen atom because it's there. So on the reactant side, the number of oxygen atoms are 3, and on the product side it's 1 plus 2, that is 3. So this equation is already balanced. We need not to balance this equation. So as this equation is balanced, so we can apply the law of conservation of mass, which is total mass of reactants is equals to total mass of products. So now let us find the total mass of the reactants. In this case, we just have one reactant and the total mass of product, so that we can just substitute the value in this equation. I will take this missing value of carbon dioxide as X gram. And now the total mass of the reactants, in this case we just have one reactant, so it will be mass of calcium carbonate, that will be equal to just 10 gram. And the total mass of the products here, it will be mass of calcium oxide plus mass of carbon dioxide. So this will be our 5.6 gram plus X. So we have just calculated the total mass of the reactant and the total mass of the products here. So as per the law of conservation of mass, the total mass of the reactant is equal to total mass of products. Here we just have one reactant, so it's 10 gram, it's equals to 5.6 gram plus x. So x will be equals to 10 gram minus 5.6 gram. So the value of the x will come out to be 4.4 gram. So the mass of the carbon dioxide formed is 4.4 gram. Thank you very much for watching this video on practice problems on law of conservation of mass. For more videos, you can visit our website transelearning.com. Have a great day.